So this is number 9 from the team run, and it reads, a rectangle ABCD has perimeter 58 and the diagonals are length 25. And we want to ask, what is the area of ABCD? Okay. So the first thing we want to do with any like geometry or shape question is we want to draw the diagram. So this one's pretty basic. All we have is a rectangle. So we draw a rectangle out. Doesn't have to be super great as long as it's a rectangle looking thing. Obviously mine isn't the best, but okay. So we have A, B, C, D. Here's our rectangle. And then let's say it has side lengths X and Y. And then this is also X and Y because it's a rectangle. And all the angles are 90 degrees. Okay. So the perimeter of 58 means that X plus Y plus X plus Y, this is the perimeter, is equal to 58. Or we can write this as 2x plus 2y equals 58. And that means x plus y is equal to 29. So let's just label this as our first equation. And let's do a second equation, which is the other condition that we have. The other condition we have is that diagonals have length 25. So let's just draw the diagonals here. So there's our first diagonal. Wait, sorry, they could be straighter, but there's our second diagonal. And then they both have length 25 here. So as with the rectangle, we have a lot of right angles. And if we have the lengths in the right triangle, we can use Pythagorean theorem. So imagine we applied Pythagorean theorem on this triangle right here, ACD, the triangle that I marked in red. Using Pythagorean theorem, we have the square of the two legs, which is x squared plus y squared, is equal to the square of the hypotenuse. So this is equal to 25 squared. Yeah, so this is also equal to 625. And then let's call this our equation 2. And with these questions, it's really important to know what our end goal is. So our end goal is to find the area of ABCD. And the area of ABCD, what's the area of a rectangle? Well, it's you multiply the two lengths and the width. So the area. So we have our two equations, and then we want to find xy. And this is kind of tricky because we don't see xy anywhere. It's kind of hard to manipulate, but we're going to do something very clever, okay? What we're going to do is we're going to square both sides of equation 1. And what we're going to get is x plus y squared is equal to 29 squared. And be careful when you're squaring something like x plus y. Notice that this is not equal to x squared plus y squared. In fact, if we expand this out, we get x squared plus 2xy plus y squared is equal to 29 squared. And that's because we distribute the x and the y's. And then let's say this is our equation 3. Now we have one final step, and this is to do equation 3 subtracted by equation 2 here. And what we get, so we're subtracting equation 2 from equation 3. And then what we get is 2xy is equal to 29 squared minus 25 squared. And I believe you do get a calculator on the team round. So you can now just solve for xy. We have xy is equal to 29 squared minus 25 squared over 2. And yeah, so you should have a calculator for this. So it should be fine. I think when you compute this, you get the answer 108. So you get xy is equal to 108, but the area of ABCD is equal to xy. So therefore, our final answer for the area of ABCD is just 108. So yeah, it's important to draw a diagram and then list out what the conditions are saying. And then there's that very tricky algebraic manipulation there by squaring both sides. But yeah, that's basically the summary of this question. Thank you.
This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.